The fifth and final segment that we're looking at for our triangles is the altitude. And we've heard this word altitude before. Most of you have heard the word altitude in many places. If you've ever flown in an airplane, the pilot's always talking about your cruising altitude or the altitude. The altitude is how high you are. Altitude is height. So when you hear the word altitude, you're thinking of height. Okay, that's the height. Now the altitude, like the perpendicular bisector, is at a 90-degree angle. It is perpendicular because when we measure height, we measure straight up and down. If I want to know how tall I am, and I'm pretty tall, so don't mess with me, but if I want to know how tall I am, I'm standing straight up and down from the ground. I have a right angle that I'm creating with the floor. I'm not going to lean to the left and then let you measure how tall I am from the floor up to my leaning head. I'm going to stand still. If you have children like I do, you know it's a big battle when you go to the doctor and they tell them to stand against the wall so they can measure how tall they are. They do all kinds of crazy things like get on their tippy toes and squirm and slouch and lean forward. You want to create a perfect 90-degree angle to measure the altitude of a triangle. So if I'm looking at this triangle right now, I have AF, that should be segment AF, is an altitude. You see that word altitude, you should automatically think height, 90 degrees, and that is also always from the vertex. The altitude is from the vertex at 90 degrees. Remember, a perpendicular bisector does not hit the vertex. Only in an isosceles or an equilateral triangle. We'll talk about that a little bit later. But an altitude hits a vertex. The perpendicular bisector 99% of the time does not. So it says AF is an altitude. What that does is that tells you automatically that these are right angles. That is your height. That is an altitude. So it says find the value of x if the measure of angle 1 is 8x plus 18. Well, what do I know the measure of angle 1 is already because this is an altitude? 90. So I know 8x plus 18 is equal to 90 degrees. Okay, real simple. 8x plus 18 equals 90. So I'm just going to solve for x. I'm going to subtract the 18. So 8x equals 72. And then I'm going to divide both sides by 8. So x equals 9. Because 9 times 8 is 72. So that's x. If I actually want to make sure that I got the right answer, if I plug x back in, if I plug 9 in there, what should I get? I should get 90. You're absolutely right. You have answered so many questions right tonight. I'm so proud of you. So 8 times 9 plus 18. Well, 72 plus 18 is 90. Check. Boom. Did it right. All right. So let's move on to number 14 because that's the one that comes after 13. So I'm looking here for my pen, and it says FJ is an altitude, not attitude, even though I have one of those. It's an altitude. That automatically means vertex 90 degrees. So FJ is an altitude of triangle GFH. Now I want you to notice something, okay? I'm going to make an outline of triangle GFH. Here's an outline of triangle GFH. What kind of triangle is this, besides a pretty purple one? What kind of angle does this look like? This looks obtuse, right? Okay, here's a special situation. In an obtuse triangle, an altitude can be outside of the triangle. In an obtuse triangle, an altitude can be on the outside. Look at my triangle. This is the top of the triangle, and I want to know how tall it is. Well, how tall it is remember, straight down at a 90-degree angle. That's this right here. That's a 90-degree angle with the ground. Because here's your ground right here. This is not 90. There's no way I can go from vertex to this side and make a 90-degree angle inside the triangle. It's impossible. I can't do it. In order to make a 90-degree angle, I have to extend this side, it's an imaginary, come outside the triangle. So, if the measure of angle H is 35, let's get a different color here. If the measure of angle H is 35 degrees, find the measure of angle JFH. JFH, okay? I want to know this angle right here. Not just the triangle part, but outside. You have to pay attention to what they're asking you. All right. Let's imagine this bigger triangle here. That's 35. What's the green angle here? 90. So how would I find this big angle up here? What do the angles of a triangle always add up to? Triangle sum theorem, 180. So 35 plus 90 plus JFH, that's this whole angle right here. Notice that's not just the triangle, the little triangle, that's all of them. Plus the angle we're looking for, and I'll actually write it in there, sorry. Measure of angle JFH equals 180. 35 plus 90 is 125, plus the measure of angle JFH equals 180. Let's use a different color because that's just what I want to do. So I'm going to subtract 125 from both sides. So the measure of angle JFH equals, ta-da, 55 degrees. So that's what that big orange angle is. It's 55 degrees. Okay? Not this one. This one, the whole thing. Be careful with what it's asking. Okay? So let's look at the next part. If FJ is 24, that's the altitude. JG is X, and FG is X plus 18. Use the Pythagorean theorem to set up, but do not solve, the equation for X. Do you see how we have a right triangle? So X squared, that's A squared plus 24 squared equals X plus 18 squared. With the altitude, you're going to start using the Pythagorean theorem. A squared plus B squared equals C squared. And the altitude is going to create right triangles. But it said don't solve, so we're not going to solve because I'm lazy. I'm going to do the minimum. All right, let's look at the last one. Yay! Everybody excited. Woohoo! All right, so let's look at the last one here. Label any right angles in your figure. Well, it says in the diagram, because I can't talk, QW is an altitude. That means vertex 90 degrees of triangle RQP. So QW, that means it's an altitude. That means these are 90s. Does not mean it cuts that angle in half. It means it goes from vertex to the opposite side at 90. Name two right triangles in the figure. Well, we have QWR and we have QWP. Those are our two right triangles in the figure because they have a right angle. That's the definition of right triangles. Right? Right. Right. So if the measure of angle QWR is 12x plus 6, and the measure of angle QWP is 10x plus 20, set up and solve an equation to find x. Well, what do you know about these two guys? They're both 90, so they're equal. So that means 12x plus 6 has to equal 10x plus 20. So, moving on. I'm going to subtract the 10x from both sides. So 2x plus 6 equals 20. And I'm going to move the 6 to the other side. So 2x equals 14. And then I'm going to divide both sides by 2. So x equals 7. And it just tells me to find the value of x. So I'm done. However, if I want to check my answer, when I plug 7 in for x here, and I plug it in for x here, I should get two equal numbers, right? And what should those two numbers be? This is an altitude. What angles are these? They're 90s. So let's do 12 times 7 plus 6. I'll plug it in the 7 here. 84 plus 6 is 90. Ding, that one works. Let's try this one. 10 times 7 plus 20. 70 plus 20 is 90. Ding, ding, we win. Not really. So they're both 90, so we got the correct answer. So that is how you use the altitude.